In this video, I will show you how to run a linear regression on SPSS. So select Analyze, Regression, Linear Regression. And here we have the window for it. In the dependent variable field, you'll put your dependent variable. So whatever you're trying to predict, remember, if this is a correlational study, we cannot actually talk about causation, all right? But we still have a predictor and a criterion or dependent variable. So in this case, let's put moral permissibility as the dependent variable. And we'll put openness to experience as the independent or predictor variable. Openness to experience is simply one of the big 5 personality factors, and moral permissibility is the tendency to believe that normally taboo or immoral actions might possibly, in some circumstances, be permissible. Okay, so higher scores mean that people have better imagination for exception to the moral rules, right? Okay, so we put in our dependent variable and our independent variable, otherwise known as the criterion, moral permissibility, and predictor variable, the independent variable, okay? If we click on statistics, we already get estimates, okay? For this, we really don't need any more for this class. We can click on descriptives if you want, and that will give us the correlation between the variables, but we will know that anyway. I'm gonna go ahead and click it so we can see something. Hit continue. Okay, we don't need anything else for this class. Hit OK. And here is our regression output. Now, because I selected descriptive statistics, it gave us the mean and standard deviation for our dependent or outcome variable or criterion variable, and openness to experience, which was our independent variable or predictive variable. All right, it also tells us the zero order correlation between the two, okay, which was 0.129, all right. Okay, so scrolling down, we see a lot of things we don't need to worry too much about. It tells you what variables you use and so forth. Here we're mainly interested in these 3 tables at the end. All right, so first we see the model summary, which gives us the R square value, which is 0.017, and adjusted R square, which is 0.014. In the NOVA table, it tells us the sums of squares regression. Let me get a pen here, hang on a sec. It gives us a sums of squares regression, sums of squares error or residual, and sums of squares total. All right, gives us our degrees of freedom for the predictor, for the error, gives us whether or not the model as a whole was significant. And now here's what we're really interested in for regression. We're interested in this table that says coefficients. All right, underline this properly, okay? So here we have our intercept, okay, which in SPSS, they put it as a constant, but it's called constant. Our intercept is 1.496, which rounds up to 1.50. Remember, in case of doubt, I always want things reported to 2 decimal places, except for p-values, which we'll get to later. Next, we have the slope for openness, our predictor variable. The slope is 0.073, all right? We can see the standardized coefficient. This is the standardized slope, which is exactly the same as the correlation between the 2 variables when we have just 1 predictor variable. All right, we also have the t-value and the p-value for the slope, which we will learn about later. All right, so what if you were asked to write out the regression equation? All right, so remember y equals this. Right here we have the intercept, which is 1.50 plus the slope, which is 0.073, times x. So 0.07 x, all right? That is the regression equation. So, for example, you might have to find out what the predicted value of y would be for a given value of x. So, for example, if I asked you what y would be for x equals 2, you would just plug it in. Y equals 1.50 plus 0.07 times 2. All right, which is a pretty small value, right? So what you normally do is you take out your calculator if it was more complicated. So this is 1.5 plus 0.07 times 2 is we should actually put a 0 in front of it, 0.14. Okay. And remember, actually, all of these should have a 0 in front of it because they can be greater than 1, right? So 1.50 plus 0.14, right? That's 1.64. So here the answer would be y equals 1.64, right? Of course, it's probably going to be different, but I just wanted to walk you through that, all right? And we will stop right here.